1.4, algebraic methods for evaluating limits. Example 7 gives us our first new algebraic method for reconciling 0 over 0 or infinity over infinity. Remember, that's kind of what we're after. So example 7, I've given the name RATCON to. RATCON, which is short for Rationalization Conjugation. And pre-cal is testing tomorrow, and they're going to have to do rationalization, RATCON. They're going to have to do RATCON tomorrow. So it's rationalizing by multiplying by the conjugate over the conjugate. We're working with expressions, and we have to multiply by clever forms of 1 or add clever forms of 0 and stuff like that. So when will this method work? Well, let's look at this example, 7a. We have the limit as x goes to 0 of some function. Never, not first. What do we always try? Substitution. Sparky, what do we get when we plug in a 0? You are full of spark. Very good. 0 over 0. Is that right, Sparky? Yeah. No, yeah, that's okay. Everyone can be Sparky because we're just fired up, right? All right. 0 over 0. All right, so 0 over 0. Now, 0 over 0 means the function's undefined there, but there's a hole and the limit will exist, right? And we got to find it. Now, what methods do we have so far in our mathematical tool bag? Divide out. That's really it, right? So the bad guy factor is always worth identifying, okay? Because we need to eliminate the bad guy factor that's causing the 0 over 0. And if you don't identify the bad guy and you try to eliminate some stuff, you might have collateral damage, and you don't want that. Okay, so the bad guy factor in the bottom is the x factor, right? I have two terms in the top. See them? One term, two term. Is there currently a factor of x in both terms that I could factor out and divide out? No, there is not. There is not. So I need another algebraic method. And how are we going to do that? Yes, very good. Y'all know that rationalization usually occurred when you had radicals, right? And to rationalize an expression means just to get the radical out from where it currently is, either the numerator or the denominator, by reintroducing it to the other side. Now, because it's two terms, you can't just multiply by radical over radical. You have to multiply by the what you get of these? The conjugate. So we are going to rationalize this thing by multiplying by the conjugate. Hence the name RATCON. Now, remember, you're changing the sign betwixt the two terms and not the sign under the radical itself. So we really just multiplied that expression by a clever form of what? 1, which is the identity element of multiplication. So it's all good. What is the conjugate of x? It could be, because that could be 0 plus x, and the conjugate would be 0 minus x. You're certainly welcome to multiply by negative x over negative x, Kevin. But here's what I think might not happen. You might not be able to get rid of the x factor by doing that. It's not wrong, but it's not going to lead you where we want to go. You can multiply by 7x over 7x, or sine of x over sine of x, as long as it's equal to 1. But look and see why this works. If we expand out, and we make sure we write the limit, if we expand out the conjugate factors in the numerator in this case, good things should happen. By design, the radical should go away. Square root times square root is radicand. And then you're going to get a minus radical on the inside and a plus radical on the outside. Those go away. They're gone. And you're left with negative 1 times positive 1, which is negative 1. So the radical has gone away. Now, in the denominator, we have an x times this two-term dude. The question is, do you want to distribute the x and expand it or leave it factored? You leave it factored because we've already identified the bad guy as x, and we can only divide out common what? Multiples or factors, so we leave it factored. So we got x parentheses square root of x plus 1 plus 1. Now, that is equivalent to the original expression, but does it help us eradicate the bad guy? Yes. And the answer is, of course, yes. Because what happens in the numerator? What's 1 minus 1? 0. So what we've done, and I'll go ahead and write that step, we've exposed the bad guy. We've left him up there totally exposed, and the bottom stays the same. And, of course, now that we've done that, what can we do with the x? Divide out. Oh, shot a blank there. Yeah, okay, there you go. And we're left with the what in the top, 0 or 1? 1, there you go. That was a warning shot. Okay, and then we got him. All right, so once you get rid of the bad guy, once you get rid of the 0 over 0 problem, what can you do? Plug in, right? Because we're left with a function that essentially paves right over the hole at x equals 0, and so its y value will be the y value of the hole, hence the limit value. So once you divide out the bad guy, go straight to direct sub, and that's when you do not need to write the limit anymore. So you get 1 over 1 plus 1 is 2, so you get a half. So the original function has a hole at the ordered pair, 0, comma, 1/2, and that's the limit value, okay? So you don't have to remember the name Ratcon. What you need to remember is when you get 0 over 0 and you have a two-term dude, one of which at least has a radical, just rationalize. Algebraically, it will allow you to eradicate the 0 over 0. Okay? On part B, let's insert the missing negative signs. That's a game in and of itself. Okay? There they are. Let's do direct substitution together, and then I'm going to set you free to get Osama bin Laden. Okay? You plug in a 3, and you get 3 minus 3 is 0. And then you get the square root of 5 minus the square root of 5. That's 0 over 0. Okay, SEAL Team 6. Go for it. Yeah, I like to turn that equal sign into a big, giant multiplication symbol. There's now a sleeper sofa up for grabs, in addition to the pillow top mattress that is almost dry. You'll hide y'all's enthusiasm very well. Limit, limit, limit. Right, right, right. And then plug in. Yeah. Lost a point. Limit, limit.
Such a waste of time.
No, it isn't. You're earning points by doing that. Come on, limit, limit. Practice like you're going to play. Limit, you got it. Okay. Limit, 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 limit. Until you plug in. Once you plug in, you're good. Yeah, and you can leave it like that on the free response. What would that be, though, if you combine them? Ooh. I like that. Big old Laverne and Shirley, capital L. Oh, you're on the next one. Okay, Taylor. Yep. Limit, good. Okay. Is it 5 or 2 square root of 5? Square root of 5 plus square root of 5 is 2 root 5. Okay, good. So you do get 0 over 0. Ratcon. You have 2 terms here with radicals. That's okay. You only need just 1. But the conjugate is going to be plus, plus, and here we go. I'm going to write the limit first. I always do it first. Y'all tend to do it last. Maybe y'all should do it first. The limit. And we always expand out the conjugates. Always the conjugates, right? Radical times radical is radicand when they're square roots. Inner and outer. Cancel, cancel. Gone. Negative square root of 5 times positive square root of 5 is negative 5. And in the top. Oh, by the way, we never identified the bad guy. Ooh. It's x minus 3. He's causing the 0 in the top, and there's some hidden x minus 3 in the bottom. Okay? Maybe he's in the cover of darkness or whatever. We leave the top factored. Now here's a line saver. Mr. Bain, did you take a whole other line to say that x plus 2 minus 5 was x minus 3? You did? You can do that, or you could just say x plus 2 minus 5 is x minus 3. Group it together like that and do what? You can divide it out like that. It's more fun to do it twice. And of course, when you plug in, the bell is coming, you get square root of 5 plus, and I forgot the square root of 5 there, square root of 5, and that's equal to 2 square root of 5. Okay, have a great, fantastic lunch.